going to be giving us a tour. And Tracy, if you're ready to go, we will kick things off.
All right, sounds good. All right, so I will share my screen. Let's see. Let's start with this one, and hopefully you can see some really cool shiny motors.
It looks great.
All right, good deal. So thanks for letting us be here today. In case you all don't know, Manufacturing Day is one of our most favorite days and weeks of the whole year. And actually one of our favorite things to say is that every day is Manufacturing Day at ABB, because it's what we do day in and day out across many locations in the United States. ABB in total has about 60 manufacturing locations in the United States. We are a global organization though, so we actually operate in over 100 countries. But the business that I'm part of, which is motors, mechanical, and drives, we have, I'm not going to get this quite right, but between 16 and 20 locations in the United States. Of the 60 belong to our business. And so we're really proud to be in manufacturing. We're proud to share what we do with the Fort Smith community and all the communities in which we live and operate. But in particular, we love having students come out and their parents and their teachers to see what it is we do and the kinds of jobs that we have. I've worked for ABB for over 30 years. I've been here my whole adult life. I've been around this plant and this building for my entire career, and I'm very proud of it. And I love showing it to new people and helping them see the kinds of things that we do right down here in Fort Smith at the intersection of Zero and Wheeler. We also have a plant in Ozark. For those of you who live kind of on the outskirts or live east of Fort Smith, and we make a similar product there, just on a smaller quantity, but a larger size. So what you see today actually happens in a number of different plants. But the plant in Fort Smith is our largest one. And we'll talk about that a little bit more as we get into the tour. So why did we do a virtual tour this year? Well, I think it's pretty obvious. We couldn't do things the way we'd normally do things this year as much as we'd like to. We like the open house format and all the tours that we normally do as well. But we thought, you know, we hate to miss the chance to take students behind our walls. We know that when you drive by the plant, this is what you see: solid walls, maybe a cool looking logo, but you really can't tell what it is we do inside. And we hate to miss that opportunity to show that. So we did put this 3D tour together to help you see what we do, to help students and teachers, you know, eventually on your own, starting next week, you can do this tour by yourselves. You can go through and drive it yourselves and see what you can click on and see what you can see. We see this as a way to complement our in-person tours. So eventually we'll get back to having everybody come out again. But until then, this is a way to give you kind of a taste. And then when you come back in and you can see more of it, you'll have a better idea of what it is you're looking at. What we liked about this is it's interactive, so students can take themselves on this tour. They can click on spots. They can learn about jobs. You know, we've picked a number of spots throughout the plant. And let me come down one more time. The plant is big. The plant is hundreds of thousands of square feet. So we really can't show you the whole plant today. But what we've done is we've followed this red path, and we're kind of giving you a little bit of the day in the life of a motor. And what we want you to see is that there are many, many kinds of jobs. It takes a lot of different jobs to make the plant run, to make a motor and build it properly and get it through to our customers takes a lot of different kinds of jobs. So we've highlighted a few of the technologies, a few of the key stations in the plant. But of those, we're really trying to highlight all the different kinds of work there are that go behind those, and what the kinds of skill sets that are needed for the different kinds of jobs as we go. So without further ado, let's go over to our plants. And Lindsay, am I still showing the presentation, or am I now on the presentation itself, or on the tour?
You're on the tour image.
Awesome. All right. So if you noticed, let me come back here really quick. When you come in the front door of our plant, and some of you have done this, there's this long aisleway that we walk down, and then we can move our way into the production process itself. So this is where we're going to start our tour, is right here in the midst. We've already machined some shafts down here, And we're starting to produce some rotor cores in here, and you're going to see some of those products as we walk along. But we're going to start right in here. We're in what we call the end plate department. The end plate are the caps that go on the outside of the motor. Here to the left, you can see that we have rotor cores. A rotor is the rotating part of the motor. It's the piece that's going to actually turn when we plug this motor in. But if we had come in that front door, we would have walked down this aisle and we would have walked here. And now we're going to go by. The rotor department is that way. End plates are over here. This is a supervisor's station. I am going to try to do this slow. Sometimes I apologize in advance. If I go too far and too fast, it can be kind of dizzying. So I'll try not to do that, okay? So here's our very first stop. And in our first stop, we're going to welcome our guests to ABB. And this is where I want to tell you that between Fort Smith and Ozark, we have more than 2,000 employees in this area. We also have a facility down on Wheeler Avenue that you may have seen in the past, where we actually do aluminum die casting. And there's aluminum that gets made into these parts down there on Wheeler Avenue. But between the plant, which employs about a little over 1,000 people, and the hundreds of people that are in the office building next door, we support this business globally. We are a global motor business. And from there, we have jobs in sales, supply chain, information services, and all of those folks are there to support what this plant builds and making sure that they have all the tools and support that they need to sell those products globally. This plant in Fort Smith makes more than 5,000 electric motors every day. And you might ask yourself, if you haven't asked before, so what is a motor? What is an industrial motor? What do we do with 5,000 of those a day? Well, if you think about things that turn, so there's an engine in your lawnmower, there's an engine in your car, those are run on gasoline. The motors that we make things turn also, but ours are electric. So you plug our motors in and they make other pieces of equipment turn, like fans, like pumps. Those things use electric motors to turn. So as we go through the plant today, be on the lookout for motors, because we run equipment throughout this whole plant, and every piece of equipment in this plant has a motor, like what we make, to make it run. But what you also might know is that throughout Fort Smith, motors like those that we make are used to deliver fresh water from downtown to our homes. They're used, if you're in school today and the air conditioner is running, the motors that we make may be running the fans on those air conditioners. There is a bottling plant in town that uses motors to move those bottles down that conveyor line. Sometimes when you drive through Oklahoma and Texas, you see pump jacks out in the field. Motors like we make run those pump jacks to drill oil. In the hospitals in town, there's elevators that lift people up to the top floor. Those all need motors. Throughout our own plant, we have very large 2-story garage doors that use our motors to keep those open. And of course, there are a few distribution centers in town that move packages. It takes motors to move those conveyor lines to move those packages. So that's what we do in Fort Smith, and that's what our motors do. So as we move through the plant, I want to highlight this screen up here. You'll see these screens throughout much of the plant now. And what you see on this screen is a tool called ThingWorks. ThingWorks is a new tool that we have. It's a pretty cool tool, and it takes some special skills to run it. If you have a chance to be on our panel discussion tomorrow with Johnny McCusker, Johnny's going to tell you more about ThingWorks and why we chose to use it. But ThingWorks is a way to collect data from the machine. And so the data can be reviewed by the operator to make sure the machine is running efficiently, but it can also be looked at by the whole plant. The plant manager could look at it, or somebody like Johnny who sits in another building, perhaps in another part of the country, he could actually review the data that's happening in that machine as well to make sure it's running properly. But it's one thing to have the data. What you really need, though, is a person who can program that tool. So we use advanced manufacturing technicians to program ThingWorks for every specific machine. Every machine gets its own program. And for the kind of work that machine is expected to do, we're going to start capturing cycle times, start and stop times. How long does it take to change it over, so that we can better schedule those activities and make sure the machine is being used the most efficiently as possible. So as we go through the plant, and of course we have aisles, and we have other parts and processes along the way, we're going to come up to what we call the Hobbing Cell here on the corner. Now you can see that this Hobbing Cell has a ThingWorks display as well. Somebody else that is involved in the ThingWorks, oh, see, we went too fast. This is what happens if you go too fast. But that also makes it kind of fun. So let me come back here for a second. Let me back up. This is like learning to drive and not doing it well. But this is the fun of the 3D map tour, I will tell you. All right, let me come up here again. We're going to try this again. I can move along the plant this way. So, as I was saying, a continuous improvement engineer looks at the data that comes out of ThingWorks, and they really want to use that data now to find best practices and best ways to keep the process most productive. In order to be that kind of in order to get that kind of job, click back on here, it's important that a continuous improvement engineer or a specialist have really strong analytical and problem-solving skills, and you need to be able to multitask. You can see this is a really busy environment, and this type of data exists on hundreds of machines. So you have to be able to work on various projects at the same time. This kind of job really needs to have a good understanding of electric motors. So this would be a job you could aspire to once you've come in, because it helps that you understand the processes in order to do this kind of analysis. Let's back up a little bit and look at this machine itself. If you were in this machine, the Hobbing machine, you're going to take raw stock like what we see over here. We're going to make it be really pretty like the one that's here. And so the question is, how do we do that? How do we do that by placing it in this machine? What happens when you shut the doors? Well, the person who runs this machine is a CNC machinist, and they actually run programs on this machine, and they shape this metal to go from something that's, very plain and ordinary to something that's got a lot of detail and a lot of cuttings on it. And it's his responsibility, or hers, to make sure that the measurements are exact, that the piece is cut exactly as it's supposed to, so that it performs the way it is. So a machinist has to be really good at map, blueprint reading, air gauge reading. You're here by yourself. You're not part of a team at this machine. So you really have to be self-motivated, very dedicated, and you have to measure all your parts yourself. Nobody's checking you. If you're wrong, if you turn on a part and let it go that's not correct, you're going to ruin the motor down the line, and you're going to hurt a customer's order. So really, really important. One note, a CNC machinist is one of the highest paid hourly jobs because of the detailed amount of accuracy, math, and attention to detail that this job requires. All right, so I didn't want to go to this part of the plant, so we're going to go back. Thank you. And let's go over here. So we've just left the hobbing machine. It's right there. We're going to work our way over to the winding area, but first I'd like to show you this little white box. Oh, by the way, there's a motor running a piece of equipment. I think we should have a quiz at some point to see how many motors people can see as they move through the plant. But that little white box, that's called a smart sensor. And a smart sensor allows us now to capture data on the equipment of our own motors that are running. And it lets us see if it's running too hot, does it have vibrations, does it have problems that might indicate that it needs some help. But the person who monitors that is a maintenance technician. And so a maintenance technician can actually monitor that white box from anywhere else in the plant or anywhere else in the country. They can do it with their phone when they walk by, or they can do it from a workstation someplace else. And they're making sure that that nothing looks like it's about to go wrong. You know, they do maintenance on the equipment on a regular basis, but if something were to get off between cycles, the last thing you want is for that motor to shut down and this gentleman not be able to run his machine. So they're watching for trends and things to make sure that they can troubleshoot an issue before it becomes a shutdown issue. This kind of job is really somebody who's been trained in industrial maintenance. You have to understand electrical and hydraulic and control system applications. It's good if you have PLC and troubleshooting experience, because there's a lot of troubleshooting involved in a maintenance role. These people also create plans, preventive maintenance plans, so that you can make sure the equipment is maintained properly. And you really need to be comfortable working with all sorts of mechanical products, including conveyor belts, air compressors, motors, hoses, and pumps, those types of things. So now let's work our way back towards winding, and we're going to just go this way. And you can, when you get a chance to play in here yourself, you'll notice that in each of these scenarios, wherever you stop, you can look all the way around. But the way we communicate to each other, you can see the green lines. This means everything is in its place. That's part of our 5S process, where everything is situated properly and it's in its designated area, so that's not in anybody's way. So let's keep walking through. We're moving here. Oh, another motor. Bet you saw that one. You know, one thing we want to make sure people understand is that at ABB, safety really is one of our priorities. It's actually the most important thing, because if we don't have safe operations and people there to do the work, you know, we really don't. We need everybody to come to work every day in order to take care of our customers. Most of the folks at ABB have been with the company for more than 10 years. And we really want people to act at work as safely as they do at home. And we want you to come to work, be safe, and go home in a good condition back to your families. So you will see safety precautions. You'll see designated walkways. The day I was out here, I have to wear a vest when I go because this isn't my building, so they can tell that I'm a visitor. We all have to wear safety glasses, steel-toed shoes, ear protection in certain areas of the plant. So we do want to make sure we keep the environment safe. And there are a number of benefits that we get by working at ABB. But I think one of the ones that we really think is most important, is our tuition reimbursement program. So we believe an education is something you can't take away from a person, and that if you as an employee are willing to invest in your own education, something that'll help you better yourself on your job, then we're willing to invest in you by reimbursing you for the money that you spent to do that. You know, one of the things that we find, I think many of you know, we have an apprenticeship program. And one of the things that we've talked about with the apprentices and their parents is that if you have the right skill set and you're able to come work for us straight out of high school, you don't have to not go to college. You may decide to go to college a few years from now, but if so, we can support you with tuition reimbursement, so that that's not an out-of-pocket cost for you when you do decide to go back to school. So we're pleased to offer that. So let's come over now to a robotic winding cell. So the robotic winding cell, you know, this concept, we've had a number of cells brought into the plant now over the years. And what a robotic winding cell does is it allows us to take 4 or 5 different operations where we can run them through the same operations on a routine basis. So if you have a product that you only make a couple of a year, then that's going to stay a manual process, because it's hard to automate something that only happens a couple times. But if we have out of 5,000 motors, 1,500 of them that get treated the same way, then we can automate those processes and allow for that repetition to take place. That also allows for 1 or 2 operators to oversee more work with more authority and responsibility, and allow the robot to do the repetitive work for them while they maintain the system. So in this process, we're creating the outside part of the motor. Earlier, we saw the inside part. This is the stator. This is the piece that stays stationary. And what we're doing is creating all of the stuff that goes in that and getting ready to move that down the line and put the 2 parts together. There's a motor. Anybody saw that one? So within a winding cell, you know, one of the key jobs in a winding cell is the manufacturing engineer. Someone had to design this entire platform, and a manufacturing engineer does that. He decides what are the 4 or 5 operations, how would they fit together, how would you feed things from one to another, and then he works with the vendor to help us figure out how to build such a thing. Once it's there, they have to help program the system, they have to maintain the equipment, and they're always looking for ways to improve the flow and improve the system. So manufacturing engineer is a key role in this job. You see we have a robot in this cell. We have actually more than one, but a manufacturing engineer with automation uses software like what you see here and tools like this pad to program that robot. And so each robot comes, this happens to be an ABB robot, and we do use Robot Studio, much like you would see at UFAS or in some of the classrooms in the local high schools. The manufacturing engineer automation uses this software and this joystick to program this robot to do the jobs that we want him to do. So he's going to use a joystick and move the robot to pick up the part, bring it back, go over here, place it into the next position, come back here. And as he's doing that with the joystick, the software is recording his steps and he's making sure that everything follows into the right path before he records that program. So the skill sets of a manufacturing engineer: automation, understanding PLCs and HMIs, that's going to be very valuable. Networking, Visual Basic. This is really a STEM position. This is a job, where somebody who's been in engineering or has a STEM field can understand those kind of work. So that's a good background. You got to be able to troubleshoot mechanical and electrical issues for robots, control systems, machine operations, and you're going to have to be able to read blueprints, understand AutoCAD. And this is another one of those jobs where you are kind of in charge of a project. So you got to be self-motivated. You have to be able to teach others how to come along, and you got to be able to balance speed and accuracy. All right. Oh, stop. This is the fun part, right? Okay, let's go back because we weren't quite done there yet. Oh my goodness gracious, we've gone too far. Well, we'll come back. All right, what I wanted to talk to you about next is the safety engineer. So let's go back over to that winding cell. All right. So you can see that the cell is quite large. We're only seeing a portion of it from here. You can walk around the whole thing, but it does do multiple functions. So one of the things that we do talk about, though, on a cell like this and throughout the plant is a safety specialist. And I've already mentioned to you that safety is pretty important to us. But you can see this actual system here on the fence of the system. And that is what we call our lockout tagout process. So a safety specialist designs processes that really keep employees from getting hurt and guests from getting hurt. So lockout tagout is one of those processes, which means that we ensure that the entire system is shut down. It's locked until everything is shut down before a person can go into that space. And that ensures that no one can get hurt by moving equipment. And that's the safety specialist's job to make sure that happens. They have to understand health and safety regulations, including OSHA and work comp. They have to understand electrical safety. They have to think ahead of what do I need to do to protect the system in order to protect the people around it. And they have to be able to understand some pretty complex documents, legal briefs, even doctor's reports based on if somebody were to have gotten hurt in a situation. So being a safety specialist comes with a lot of skills. And then the last job I'd highlight in here is the actual operator itself. And that is the person who comes in every day. Normally you see a person back here. The way we filmed this, he was there, you just can't see him right now. But the robot cell operator actually makes sure that the whole system stays up and stays running and stays doing the things that it's supposed to do. So based on today's orders, the manufacturing engineer set up this system so that it could run all these different kinds of things. The robot cell operator is going to pick the specific programs that he needs to run to meet today's orders. And he loads in the right materials. Once everything seems to be working properly, he runs the cell and he keeps it working until that job is done. All right, so we're going to go back to the back wall of the plant now. We're going to just start to transition down here. We can see, that's where we've been. We've got insulation paper. That was part of what went into that cell. These are steel laminations out of St. Louis. They went into that cell. So these are the products that are feeding those machines. So there's a lot of processes going on in here. But what we're trying to do is we're going to get down to this next section down here where these spots are. We are now going past a varnish line. So we have two processes in the plant. This was actually the piece that we just built inside that stator assembly. They now go through a varnish dip process where they are completely encased in a covering to help protect the inside and to keep the wiring very tight and close together to make sure the electrical connections stay good. But what I want to show you down here is an AGV. I'm going to come back to it from the other side in just a second. So AGVs, we've been using these automatic guided vehicles for a couple years now. And we use those to where we don't have the room to support or to store all our raw materials. They bring the raw material to the operator when he needs it. So at the winding machine, we saw that we had some insulation paper there and some lamination. But for the machines down here, we want to do two things. We want to deliver product and raw materials to the machines that are ready for it, but we also want to use them where there's a lot of people, because what we don't want to do is have forklifts moving where there's a lot of people. And so this isn't not only an efficiency measure using AGVs, it's also a safety measure by not having forklifts in a people heavy area. The other nice thing about AGVs is they are faster, they're lighter weight, they can see all the way around, they have 360-degree vision, and of course, they're less expensive than the forklifts are. They can bring entire pallets of raw material over to the machines, or they can bring other small parts on a just-in-time basis. So we've got two kinds of folks who work on the AGVs. One are our apprentices. So we've got a couple of apprentices working with the AGVs right now, and their job is to help program those AGVs, help them find their pathway to the operator that they need to go to, and help troubleshoot when they don't work the way that they are supposed to. So what does it take to be an apprentice for us? Well, this is a joint program that we're doing with UFIS. A couple other companies in town are having apprentices through this same program. So you have to be involved and enrolled in one of the formal career and technical programs at UFIS. You must be going into your senior year. And we really hope that you're interested in manufacturing. And if you are, we'd love to talk to you. During the summer, you come out here and you work for 40 hours a week and get paid. It's a full-time paid position over the summer before your senior year. About 20 hours during the summer a week is going to be coursework here on our campus with a UFIS instructor. And then the other 20 will be out working in the plant on a project like the AGVs. During the school year, our apprentices come to work for us 4 days a week for 3 hours a day, but they're also enrolled in UFIS classes as well as the high school programs that you're in. So we're on our second apprentice class, and we really, really are enjoying the program. The other job that's critical to the AGVs is a manufacturing engineer. So the manufacturing engineer designs the overall process and the tools that are needed to deliver those parts. Do they need, what does the rack storage look like that they stay in? What are the tools that they need to carry in order to deliver those parts? And it's their responsibility to use Lean Flex Flow methodologies, Six Sigma, to do all those things to improve safety and quality. They may have to design some new tools and platforms and things for the AGVs to use, but they're really interested in making sure that the work is standardized and that the processes are consistent. A manufacturing engineer is familiar with CAD, again, reading blueprints and copies and drawings, got a really strong analytical and problem solving skills. You may see that as a trend through a lot of these jobs in manufacturing. An automation background is a benefit. And I would say, again, these are multitaskers. These are people working on multiple projects at one time. Not many of us have the luxury of just getting to work on one thing like an AGV, but our manufacturing engineers are working on projects throughout the plant, as you've seen. I'm gonna have just a little bit of a glitch right there that we're still working on. So we're gonna go on up to, we're gonna turn the corner now and go over to the assembly side. So now we're in if you had come through the front door and turned left, this is where we are now. This is assembly. So for the last 2 or 3 days, parts are being made all through the plant, and they're all coming over here to the end. We're all by the end of the plant. We're by the back door almost, and they're all lining up. And back here in the background, there are people building these motors. They're all coming together. We make around 250 different kinds of motors every day. And if we make 5,000, that means each order is only around 20 pieces. So you can see that motor is different from this motor, which is different from this motor, which is different from this motor. And the builders on the assembly line built each one of those and brought them over to this section of the plant. So as they come through, one of the things we have to do in assembly is put them through their final test. So the motors have been tested along the way to make sure that they work electrically, I should say. But today's final test, everything is together now. It has the ends on it. It has all the wiring on it. It's about as finished as it can be. So we're going to make sure that we have all of the right electrical connections. So we test the motor several times, but here a test panel operator is going to verify that everything works properly and that the motor runs without any glitches, without any defects. If it goes past this point and it doesn't work properly, then it's going to fail a customer. So every single motor has to pass test at this point in order to move on to paint and packaging, or else it can't be sent to a customer here. Test panel operators are normally shadow and are trained by an existing operator. They have to be very comfortable working around electricity. And as such, they have to wear special safety shoes, and you can't wear any jewelry in this position because of the electrical environment. So once they pass final test, we move on down to paint. So here's a kind of a backup view of the paint. Here they are, they're still unpainted, and from here on down, you can see they're beautiful as they go into the oven. Oh, well, I do want to tell you about paint real quick because it's kind of cool. So we're going to go back to paint. So because we produce more than 250 kinds of motors every day, you can imagine that we need a lot of different colors of paint. Surprisingly, there's only seven, let me make sure I say that right, 7 common colors, and those come in through these pipes up here at the top. But we can do between 250 and 300 colors. And if you need that, then the painter will go off and mix a special color for your motor to make sure it's what you want. But generally, we have 7 that come in here standard. It includes this gold color, which is just for the motors that we make. If you see a motor that has that color on it out in the field, then you know that that's ours. And if you go through any other plants in Fort Smith on a plant tour and you see a gold motor, you'll know that that was probably made here in Fort Smith. Painters also require training, much like a test panel operator, by other painters, and it takes 2 to 3 weeks of training to learn the nuances. It's definitely an art, not a science of painting, but it's very, very important that these be painted properly to give them a good look and a professional appearance. So then the motors go through the oven to dry, come out on the other side. And after we come out on the other side, we head to packaging in order to be finalized. Along this way, they're picking up, you can see now we've started to add some labels and we've started to add some paperwork to go with those motors. As we cross this line, this screen up here at the top will tell us how many motors we've completed so far this shift. Let's see if we can see what that says. On the day that we did this, it looks like we had 2,522 motors had gone through so far on this work day, the day we did this. So now we're going to move into the next building. Normally, we have to walk on that side of the aisle to be safe, but we got permission to come straight down the aisle this time. So in the packaging department, the product comes in from the left-hand side and it circles all the way around here, and then it gets boxed and it goes off to be sent to distribution. So at this point, you're given your final visual inspection. We're making sure it all looks good. There's the stickers aren't on crooked, nothing looks askew. We don't want anybody to open the box and be very disappointed in what they saw. Everything is securely wrapped to the bottom of a base and then placed into a box. And at that point, the motor is either going to get shipped straight to a customer, or it's going to go to the distribution center, which is across the road from this plant. And as you come out here, sometimes the buses park over there, but that's where we store all of these motors. Otherwise, we have more than 20 warehouses out throughout the United States that are close to customers, and we move a lot of our inventory there so that if your motor goes out tomorrow, you can get one tomorrow and you don't have to wait for it to come from Fort Smith. So I'll just take you down here. As you can see that the motors continue to come down this line. And as they come around to the end, they're doing the visual inspection over here. And now they're going to come this way. And as they come this way, here's where we're going to wrap them. We actually put like what looks like saran wrap on each one. They're on the boards that they're going to be on. And now that's going to set down inside one of these boxes. So the box gets laid down on top. But you notice it's just a whole box. he puts it down over the top, and then it goes through this really cool machine right here, which you'll love to see this when it's actually running, because obviously we can't see it move now. But this box folds the underneath and tapes it, and folds the top and tapes it, and sends it out the other way. So that's probably one of my favorite machines in the plant, I have to tell you. So with that, I say I hope that you've enjoyed coming back into ABB and seeing behind our walls. It's we hope to be able to show it to you in person one of these days and get to see it moving and get to smell the paint and hear the machines, because it is very exciting and it is very interesting to see all that it happens. But one of the things we want you guys to know is, if you are interested in a STEM career or a manufacturing career, please talk to your career counselors, talk to your teachers, talk to your parents. There's a lot of options these days, and we think that there's some very good options out there. If you think you're eligible to apply for the apprenticeship program, we really hope that you'll do so. The folks at UFAS would love to talk to you about WOTC. The folks in the Fort Smith school system would like to talk to you about the new Peak Innovation Center. And we would love to talk to you about coming to work in smart manufacturing, because we really think that you guys have a lot of potential. We think that you understand how to do a lot of the things that we need to do with tools like ThingWorx and with our Agvs and all the robotics. We need people who can be smart about their thinking, and we hope that that's some of you. So thanks for playing along on the tour. This tour will be live on the Manufacturing Day website this Friday, so that everybody in the United States can get in and play with it and work their way through our plant. When you do that, as you saw, I was going through the map up here, that you can jump ahead on the map. You can also sort through all the different jobs that we talked about and all the stops that we made, and learn more about each one of those based on where that job was in the plant. All right.
Awesome.
And I'm getting ready to hand it over to Lindsay. I'll say one more thing, if I can. We are doing a STEAM experience this week along with our friends at Edge Factor. We're doing this across all of the US, and lots of other companies are using this experience as well. For the teachers on the call, this experience will be free to all teachers for the next 30 days at least. And so if you don't get a chance to go through the content this week, the career profiles, the job descriptions, the videos, you'll have more time to keep going through these throughout the month of October.
Awesome.
All right.
Tracy, we did have a couple questions that came through the chat.
Okay.
So if you, the first question here, how many different tasks can the robots complete? That came through when you were talking about the robots.
The winding cell. So the robot can complete as many tasks as you can assign it to do. It depends on how quickly you want it to move from task to task. So within that cell, I would say it probably moves things between 5 different tasks. And that's primarily what the robot's doing in that cell, is it's not transforming things as much as it's moving a part as the part is transformed throughout the process.
Okay. And then the next question, from start to finish, how long does it take to build one motor?
From start to finish, if you could just start and just build it, I think it would probably be, well, no, I don't work out there, so I shouldn't probably say this. I think it's probably less than, I'm just going to say 12 hours. And if someone wants to correct me on that, they can. Let's say 12 hours. But in theory, let's say the order comes to the floor on Monday. Because there are so many different orders in process that are going to be on the same machines, we usually give ourselves 4 to 5 days for it to get from the very beginning of the process to that assembly into the packaging area. And that makes sure that all the materials end up at the right place at the right time. So we build some cushion in there for us.
Gotcha. Okay. Well, is there any other questions that anybody wants to submit through the chat? We'll pause for just a moment and see if anything else comes through. What type of industry is your biggest customer?
Ooh, that's a good question. I would actually say, let me turn it just a bit differently. Our biggest application, the thing that we do the most of, are probably pumping applications and fans. All right, so fans, And I say those differently because pumps and fans exist in every industry. The industries we're really focused on are food and beverage, mining and aggregate, water and wastewater. But within water and wastewater, even within food and beverage, you can pump all sorts of different things. So I would say there's the two primary applications, and then almost any industry, even general manufacturing. I mean, when you see how many motors, in fact, I don't have my screen up right now, but even along the dryer ovens, there were motors all along the top running fans to cool off the product coming from the oven. So just about any industry that has movement in it, we're involved in.
Gotcha. That's a good question.
Yeah, that's a good question.
Are there any others that are coming through? Let me check. We'll pause for another moment. Okay. Well, I'm not seeing any others come through. So with that, I think we will close out that portion. So again, thank you all for joining us this morning. We really appreciate it. And thank you, Tracy. That was a great tour.
That was
fun. That's an awesome tool for y'all to be able to share in this year, especially to still be able to connect with students and with other companies to be able to have them show everything. So great job. And thank you so much.
Thanks for letting me show it.
Yes, absolutely. So this session was recorded and will be shared to all the participants. We'll share back the contact information for Tracy. So if anyone has any follow-up information or questions, you can contact her. And I see some people sharing some round of applause. So yes, round of applause for Tracy. Thank you all. Awesome. Well, again, we have other manufacturing events continuing this week. Tomorrow we will be doing a virtual tour of Train and learning about their manufacturing processes for their air conditioners and such. And then we also have another session with ABB talking about the digital technologies. So and then we have our first Friday breakfast on Friday. So we're excited for this. So if there's any other sessions you want to attend, just go to our website and you can register for those online. Again, everything is free for all of our members. So thank you all for joining. We appreciate it. Bye.
Thanks, Lindsay.
Thank you.